focus. And how many focus here we have? We have two focuses here, or two foci. Means what? It is English. In English we have two foci. What's meant by two foci? Two focuses. That means what? That means the lens, it has two foci. Why? Because it has two surfaces. Two surfaces here, it means what? It means one another in the left side, and we have another one in right side. So here we have principal axis, again the straight line that pass in the optical center, and we have the optical center here that found in P. The symbol of optical center is P, and this point is found in the midpoint of what? It is the midpoint of the convex lens or concave lens. After that we have M. What's meant by M? Center of curvature. How many centers of curvature we have? Two. One in the left side and one in the right side. Why? Because the lens, it has two surfaces. Very good, student. So here we have what? We have any lens that has two foci, and they have what? They have the two center of curvature. Why that happened? Because it has two surfaces, one of them in right hand and the other one is left hand. And we have these distances here. Distance from what? From the optical center to the focus, it's equal. Just equal what? Equal the distance from the focus to what? To center of curvature. That's called what? Called focal length. Again, this distance from the optical center in the midpoint in the lens, and we have the another point here in this distance, we have the focus. So the focal length, it's this distance between these 2 points. And we have another focal length, we have the distance between focus and what? And center of curvature. They are equal each other. So each one, that's called focal length. But the distance between what? Between the optical center and the other point is center of curvature. It's what? It's called radius, and it has the symbol R. Again, we have here the distance between optical center and center of curvature. We have this is one, this is called radius. The distance between these 2 points called radius. Radius, it has a symbol. Symbol is what? Is R. R small. So here we have an observation here. Note that we have what? We have the radius. That's equal what? Equal 2 focal lengths. Again, one radius equal 2 focal lengths. Why? Because the focal length is the distance between the optical center P and the focus, or the distance between focus F and center of curvature. But the radius, it's total distance between what? Between the optical center and the center of curvature. So this distance, it is double focal length. Again, it's very important to know this. Radius equal 2 focal lengths. It means what? It means double focal length. After that, we have what? We have the definitions of each part of this one. Number one, we have principal axis. The principal axis here, it means what? It means it is the straight line that join between optical center and center of curvature. Principal axis, the straight line. If you write, this is the key word of this definition, a straight line that join between two points. One of them is the center of curvature and the optical center. Second one, we have what? We have the optical center, P. We have P, it's what? The midpoint inside the surface of lens that passes light ray without refraction. Again, it's very important to know this. So optical center, it is the midpoint in the center of the piece or optical piece that called lens. So this midpoint pass any light ray without what? Without refraction, without any refraction. After that, we have another one. We have radius and we have focus. Radius, it means what? It means the distance between center of curvature and optical center of lens. Again, here we have the key word of each one of these definitions. So here we have this, it's the radius or the distance between center of curvature and the optical center. So here, this optical center, it means what? It means the optical center that's found in the middle of the optical piece, that called lens. And we have the focus, it's the point in which the light rays are collected. So the focus, it is the point in which the light rays are collected. Any type of lens, of convex lens, that can collect or converge light ray in one point called focus. But we have in the other part or other type of these lenses, we have diversion. It's called what? Concave lens. Focus, we have another definition about focus. It's the point in which the light rays that are collected. And we have another one that called focal length. The meaning of focal length here, it means what? It means distance between focus and center of curvature, or between the focus and what? And optical center. So here we have two definitions of the focal length. If I have the distance between focus and center of curvature is right. And we have another one, we have it's the distance between focus and the optical center of the lens, so it is right. So here we have focus and focal lenses. After that, we have very important thing here. We have passes of light rays by convex lens. Passes of light rays. That by convex lens, it means what? It means it's the passing of light ray in many cases like this. So here we have the light ray that pass inside the lens, it makes a change of its direction. So if the incident light ray that pass parallel to the principal axis refracts passing focus. What's meant by this? We have an incident light ray that falling down ray. If I have the lens like this, convex lens, and we have the midpoint here in white color is called what? It's called optical center. Very good student, I hear you. So here we have the straight line that called what? That called the principal axis. And we have how many points we have? We have 4 points, M, 2 M's and 2 F. Why? Because we have 2 M, that's center of curvature, and F, its focus. So the lens, it has 2 foci. What about the incident light ray? This is like this. Incident light ray that pass parallel to the principal axis. What will happen for this one? That's what? That is pass after refraction, passing what? Passing focus. Again, we have what? We have the incident light ray here in this case. This is what? This is the lens, convex lens. And we have the midpoint that called what? That called the optical center. And here we have the second thing. We have what? We have this one. This straight line that has 4 points. Concentrate with me very well in this one. If you draw this shape like this, it's very good. And you have high marks in your exam, and you have high marks in your quizzes. So here we have 2 points here that's called M, so it's center of curvature. And we have 4 distance here from M to F, and from F to the optical center, and the third one from the optical center to another F, and F here, or focus, to the center of curvature in last part in the left side. So they are 4 equal distances. And after that we have what? We have this incident light ray parallel to the principal axis that passing after refraction, passing what? Passing the focus. Another case, the incident light ray that passes focus reflect parallel to the principal axis. How come? If I have the lens like this, and we have the second thing, we have what? We have the principal axis that contains 4 points. These 4 points are what? 2 M's, 2 F like this. But note this. We have the focus, it is near from the lens, but M after focus. So we have what? We have the light ray that passing focus or passing through focus. So here we have this one that refract parallel to the principal axis. It is very easy. It's like the first one. But here we have in the incident light ray here that passing focus first. But the other one, that's what, or the last case, we have this one or this light ray that parallel to the principal axis. After that, so the incident light ray that passes optical center, it passes without any refraction. What's meant by this? It passes in straight line without any refraction. It's very easy. Why? Because we have the lens like this, and we have the straight line that called the principal axis that has 4 points. Every time you draw this shape, we have 4 points. M, F, and F, another F, and another M. So here we have the light ray that passes through the optical center. Here, that's called P, that pass without any refraction. It's very easy. It's straight line in the same direction. So here we have what? We have the incident light ray. Concentrate with me in each case very, very well, please. We have here the incident light ray that passes optical center. It passes without refraction. Why? Because this point that called the optical center passed the light ray without suffering any refraction. After that, we have what? We have the image formed by convex lens. It's very, very important to you also. Why? Because you have a question in any exam or any quiz in this part. So here the image formed by convex lens. What's meant by this? If I have the body in different distances, like the mirror's mister. Yes, like the mirror. Why? Because we use mirror and lenses to dimension or make the image very small or very big. I want each one of them. So here we have what? We have the image formed by convex lens. Convex lens here, it means what? It means the optical piece that reflect and converge light ray. So here, if I have the convex lens and we have, excellent, we have the principal axis. How many points we have? We have 4, mister. We have 2 M's and 2 F. Excellent, boy. So here we have what? We have, this is the body. Like the mirror, we draw the body as what? As an arrow that move up. So here we have this arrow. The light ray that pass parallel to the principal axis. The first thing we have that make refraction passing focus. And the second one, or the second light ray, like the mirrors. We have 2 light rays that passing from the head of this arrow. So the second one passing on what? Passing on M? No. Mister, passing on focus? No, no, no. But what? How come this one? Or what the passing of, what's the passing of light ray, or the second light ray that passing? So here we have an intersected point, like the mirrors or like the concave mirror. So here this point is what? It's the collection of what? Of the head of this image of the body. So here this image is what? It is will be real, inverted, and dimensioned. What's meant by dimension? Dimension here, it means smaller than the body. So here we have what? We have this one or this part of this image. It's what? It is very small or smaller than the body. Another case, we have if the body at distance equal double focal length. Here we have double focal length. Who remember this? Always remember this. We have what? We have the double focal length. It means what? Excellent, it means radius. So the body on a point called what? Called center of curvature. So here we have what? We have this lens or the convex lens, and we have the principal axis, and after that we have the 4 points like this. We have 2F and 2M in the same time, like any case of the concave mirror and convex lens. So the body on M. After that, the light rays that passes here from what? From the head of the arrow to make refraction passing focus. And the second one, mister, I know, say it. We have what? We have the another one or the second light ray passing optical center without any refraction. Very good, student. So here we have this one, and they have or these refracted light rays, they intersected point. They have intersected point. Intersected point like this, and we have the image that happened here. So this one is image will be real. Real, what's meant by real? From the last lesson, we have this one is real. We can receive it on a screen, or we can receive it or save it on what? On a piece of the paper or piece of cartoon or your body. You can receive it on any surface. After that, we have inverted. Inverted, here the arrow in yellow color, that's what? That's represent the body. In left side, it's what? It's pass or move up. We have another case now. We have what? We have if the body, the distance more than focal length, but less than radius. It's very easy to know this. Convex lens. And we have the principal axis. And after that, we have the 4 points, 2 F's and 2 M. So here we have the body between F and M. And after that, we have the light ray that pass like this, pass parallel to the principal axis, passing focus. And the second one passing the what? Passing the optical center. Excellent. So here we have the intersected point that represent this image. That will be real, inverted, and magnified. It's very clear to us. The image here, it's very, very large. Why? Because this body between F and M. And after that, we have another case. If the body distance less, the body distance equal focal lengths. Equal focal lengths like this. The image that will be after drawing this shape, we have the body at focus. And we have here, this is the light ray that passing like this and make refraction on the focus. And the second one passing the optical center. Here we have what? No image. Why? Because refracted light rays, they are parallel to each other. Why? Because the first or the body that found in the focus. Another case, we have if the body, the distance less than the focal length, it's what? It's the last one. So if I have this one, the principal axis, and we have 4 points like this, F and M, like the same, like every case we have. So here the first one that pass like this and move, passing the focus after refraction. The second one that makes passing on what? On the optical center. What will happen after that? Like the concave mirror. Excellent. I have the extension of each one of them. So the extension here that makes what? That makes convex lens. That makes what? That makes image will be upright, virtual, and magnified. Excellent. Why? Because this one or the body, it's very, very near from the convex lens. Dear friends, I hope to enjoy your time with us. Study this lesson very, very well and try to draw these shapes that we have in this session. Till we meet again, thank you and goodbye everybody.